Assalamualaikum warahmatullahi wabarakatuh. My name is Syusnabila binti Muhammad Azizi. ID number EB19261. I'm the group leader for our project. In this project, we have choose and decide to design and development of fire detector in food industry. Our project cluster is technology and engineering, small medium enterprise industry, which is electrical and electronic. For our priority area or application is bakery. We have choose University Malaysia Pekan Pahang as location of research. For the duration of the research, we calculate it and it's been around one month from 31 December 2020 and to 31st January 2021. Our project member consists two member which is Nur Hasnisha binti Rahimi Hazlin as assistant and Christina Zulaika binti Hairus Nizam which is our designer. As summary of our project, the main purpose is to upgrade fire detector system to secure the safety and avoid fade warning. Baking process use a high temperature, so if fire detector have been set, this will automatically cause fade warning. This will cause a uncomfortable situation and will leading to the another problem. Therefore, we have come up with a brilliant idea which is upgrading the fire detector system. It's a low cost innovation that even the small medium enterprise can afford it. Then we move to introduction and literature review. For the project background, research is related to the fire detector system in SME industry. Researchers need to replace the old system with an updated system, making it easier for the worker to receive the true warning. For example, the worker required to produce a lot of diesel in a day and it generally will create a high temperature. A common fire detector, this device have been set to not limit the room temperature in the range of 2 to 23 Celsius to 26 Celsius, which is the indoor environment temperature. The researchers have designed and special fire detector that will beneficially for the bakery in food industry. Then we move to problem statement. However, the complexity of the existing fire alarm system in the market nowadays is too high in terms of design and structure. We have identified some problem which is fire detector keep giving false alarm in the common temperature for bakery. Needs then the second one is need to turn off the fire detector when baking process for a day when required to make high production of desserts. Besides that, the leading to the uncomfortable situation and also the demand of high cost budget. For the discussion of proposed automation model, the researchers have decided to design a low-cost fire detector that will be convenient for the bakery in food industry. This fire detector have been set up for bakery common temperature which is under 58 Celsius. Generally, fire detector have been set up follow the indoor temperature guide which is 23 Celsius until 26 Celsius. That is why when this fire detector put at the bakery, it will give false warning to the workers because it have reached the temperature limit. Therefore, our low cost fire detector that we have designed, when the temperature at the bakery below than 58 Celsius, it will give a sign which means you are safe through green LED. But when fire detector sense the changes of the temperature which is higher than 58 Celsius, the buzzer will turn on so that the red LED too. Then we move to the description of the state of the art of the proposed prototype. The nature and extent of the fire detection and warning arrangement in the workplace will need to satisfy the requirement indicated by employee risk assessment. New design fire detector are more capable and high technology compared to the old design. New fire detection system consists of one or more microprocessor-equipped cabinet with individual field device attached to the cabinet by wiring and communication protocol. The devices may include heat detector that we had, which is temperature sensor. This new fire detector more suitable to use in any case for bakery in food industry. For the for the objective in this project, the first one is to design a low-cost microcontroller-based fire alarm system. Next, to develop prototype of the fire alarm system using temperature and sensors as input to the system. The next one is to develop a prototype with the capability of customizing the system to meet with the customer requirement. Then the lastly is to avoid false warning during the baking process. Next, I will pass to Nur Hasmisha binti Rahimi Hazlim, the assistant of our project, to continue these presentations.
Hi, Assalamualaikum. My name is Nur Hashmisha binti Rahimi Hazlim. My ID number EB19203. I am the assistant of the project. So, I will present the methodology. To get proper and high quality scheme, the methodology has been separated into two phases. Phase 1, the designer decided to create a coding that will create a low cost fire detector. Besides, we'll also make a list of tools and components that we need to use to present the circuit of our low cost fire detector. The assistant also did the survey into the industries to make sure the planning can be well planned so that no problem arise. So this is the figure. So this is the figure that shows the coding for the circuit that designer have created. So this one, the circuit that our designer produced, that created for the fire detector. And then phase 2, um, the designer has started simulate the circuit and received the great result based on the software and did the animation. So figure 3 shows the simulation of the circuit when the temperature below 58 degrees Celsius. And this figure 4 shows the simulation of the circuit when the temperature is higher than 58 Celsius. After this, we will show the simulation of the circuit. Next, for the equipment and materials, we used buzzer, LED, and temperature sensor. For the buzzer's description, typical uses of buzzers and beepers include alarm devices, timers, and confirmation of user input such as a mouse click or keystroke. For the LED's description, used in electronics and automotive industries and for signage along with many other uses. For the temperature sensor, electronic device that measures the temperature of its environment and converts the input data into electronic data to record, monitor, or signal. So for the budget, we will pass to our designer, Christina Zulaika binti Hairus Nizam.
Assalamualaikum. My name is Christina Zaika binti Nizam, EB19328. I am the designer of this project. Today I will explain about the budget. So for our salary, every week our salary is 6,000, which means for 1 month each of our salary is 24,000. For the travelling and transportation, we have to to Sweet Bakery. For week 1, the budget is 100 ringgit. For week 2, 150 ringgit. Week 3, 100 ringgit. And week 4, 150 ringgit. So the project materials and supplies, UMP Pekan is our supplier, so there will be no budget on this part. And for professional service, we need a baker. The salary of the baker is 1,500 for every week. It means, so the total budget that we get in this project is 30,500.
So lastly, we have produced the appendix to get more understand on how we create how we create this project. Actually, in to determine the cost of harvesting and all. So after this, we want to show you our simulation, and Christina Zulaika as a designer will show you the simulation of the circuit and how it will run for the fire detector.
Now I will explain about the circuit of our fire detector. This push button 1 is connected to green LED and push button 2 will be connected to red LED. As for this, as we said before, the push button 1 is for temperature less than 58 degrees Celsius and push button 2 is for temperature more than 58 degrees Celsius. Now I will show the simulation of this circuit for temperature less than 58 degrees Celsius and temperature more and equal to 58 degrees Celsius. So for push button 1, this is temperature less than 58 degrees Celsius. Here, we have to play the temperature sensor. This is for temperature less than 58 degrees Celsius. The green LED will light on and it will display the happy baking on the LCD. Next, for the temperature more than 58 or equal to 58 degrees Celsius, we push button 2 and it will produce a buzzer for the sound for the buzzer and the LCD will display fire exit. So that is our so that's all from our simulation. Thank you.